All right, so now we're going to jump into activity 6.1, and we're transitioning from our previous LEQ into a new LEQ. We're still going to be in our Unit 1 or our number sense unit. However, we are getting into properties of exponents. So you can see that the new title up here for activity 6 is properties of exponents, and that's what we're going to be focusing on. We're on page 71, so go ahead and open up your springboard to there. And I want to call your attention to the two types of properties or expressions that we're going to be working with today. So in 6.1, 6.2, and 6.3, we're going to be working with all different properties with exponents. However, today we're working on simplifying multiplication expressions with integer exponents, and that just means with positive and negative whole number exponents, and simplifying division expressions. Once again, with positive and negative exponents. So the integer is just the positive or negative whole number. Okay, so before we get too far into this, I want to take a little bit of time to review some of the terminology or some of the language that we use when we're working with exponents. So the first thing here is you will have your exponents kind of written similar to this. And it's important to know that we call the 2 the base. That's what we call the base, so that's the number. And then we call the 3 here the exponent, or you may also hear this referred to as the power. Either way, we're talking about the same thing. And this exponent determines how many times the base is multiplied by itself. So here it's all about that base times that base times that base, or 2 times 2 times 2, and it's to the power of 3. So that means, and I'll do this in a separate color, that means I do that 1, I multiply it by itself 1, 2, 3 times. So right now what I want you to do is I want you to turn and talk to your partner. What is the base and what is the exponent? And what do each of them do? So turn and talk to your partner for that quick review before we move on. Great. So now there's a couple other things that I just want to refer to. So we have a couple of forms. This right here, the way that I wrote everything out. So when I wrote it out as 2 times 2 times 2, this is what we would have called the expanded form. And it's because I took the expression and I expanded it out to show exactly which operation I was doing. This right here, this form right here, is what we would call the exponential form. And the reason we call that the exponential form is because it's written with a base, and you guessed it, an exponent. Then there's one other form that we have, and it's called the standard form. And it is when we simply write the value. So 2 times 2 is 4, times 2 is 8. So in this case here, 8 would be our standard form. Okay, so now, going back to this, I want you once again to turn and talk, but this time I want you to turn and talk about what are the 3 different forms we use to express these expressions. So what are the 3 different forms that we use to express these exponent expressions? Which form do you prefer? And why? There's no right or wrong answer to that second part of the question. I just want you to think about, do you prefer the exponential form, the expanded form, the standard form, and why? Talk to your partner, and then when you're ready, push play, and then we'll continue with our lesson. Great, so now we are continuing on. We started off on page 71. I believe that we are now on page 72, and we're going to take a look at the example A. So on example A, it has given us this expression right here. So it's 7 times 7 times 7 times 7 times 7 times 7 times 7. And it's asking us to simplify this in various ways. So if I were to simplify this expression, I could group my 7's together. So here, they grouped 1, 2, 3 7's and then 1, 2, 3, 4 7's. Or you could group them using parentheses as 1, 2, 1, 2, 3, 4, 5. If you group them like this part right here, the 7 times 7 times 7, that is 7 to the power of 3 written in exponential form. And then the second part next to it, 7 times 7 times 7 times 7, that's your 1, 2, 3, 4 written in exponential form. So you have 7 to the power of 3 and 7 to the power of 4. You could do that differently. You could do it as the 2, so that's your 7 to the power of 2. And then in your other group here, pick a different color, you could do 1, 2, 3, 4, 5, which is 7 to the power of 5. There's another way you could have done it. You could have done 7 by itself and then 6 of them, which would be 7 to the power of 1 times 7 to the power of 6. Either way, you could have also said like, hey, this grouping is a little bit ridiculous. I just want to think of this as 7 to the power of 7. Either way, if you had taken any of these expressions and added the exponents, so here like the 3 and the 4, right there, 3 plus 4 is 7. Same thing here. 2 plus 5 is 7. Same thing here. 1 plus 6 is 7. So what I want you to see is that when you are multiplying exponents with the same base, you can simply add the powers. Okay, so once again, I'm going to show you. So if I have 7 to the first power times 7 to the sixth power, instead of writing it all out just like I did up there, I could say 7, 1 plus 6 equals 7 to the seventh power. And that could be my simplified exponential form. Now, when I did that and I put that into the calculator, I would get this number right here, which would be my standard form. They are what we call equivalent expressions, meaning they are equal. This is just the exponential. That's the standard. And then this right here is what we would call the expanded. These are all equivalent expressions. They're just written out so that way we can see them. So we're going to go ahead and in your notebook, I want you to go ahead and get the LEQ written down and get the multiplication expressions with exponents written down. So this is our property for multiplication with exponents. So go ahead and get that down, and then I want you to turn and talk to your partner. How would you summarize the property? How would you summarize this property? So just turn and talk with your partner based on what we did here. If we are multiplying two numbers with the same base, what would we do with the exponents? Turn and talk to your partner and try to summarize that, and then we'll check our answers and we'll get our notes in there together. All right, you should have said something to the effect of, when you multiply two exponential expressions with the same base, you add the exponents. So now let's go ahead and let's give ourselves an example. If you want to come up with your own example, that's great. If you want to follow along my example, that's fine. If you come up with your own example, you can have one of the teachers check it, and you can go ahead and skip ahead. So for my example, though, I'm going to go ahead and write it out in expanded form first. So in expanded form, my favorite number is 4, so I'm just going to use the number 4. And my expanded form is going to be 4 times 4 times 4 times 4 times 4. I'm going to go ahead, I'm going to group these three together. According to the associative property, grouping doesn't matter in multiplication, and then I'm going to group those two together. All right, so that's my expanded form. So now I'm going to go ahead and I'm going to write this in exponential form. So this would be 4 to the power of 2 multiplied by 4 to the power of 3. Because I have 4 times 4, that's the 2. 4 times 4 times 4, that's the 3. Then I'm going to go ahead and I'm going to write this in simplified exponential form. So in this case here, this would be 4 to the power of 7, because 4 to the 2, oh, I messed that up. Whoop, 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 whoop. I'm doing wrong math. So 4 plus 2 plus 3 equals 4 to the power of 5, not 7. I have no idea where I got 7 from, but it should be 4 to the power of 5. So if I go back up here, 1, 2, 3, 4, 5. Perfect, 4 to the power of 5. And then if I wanted to express that in standard form, I could go ahead and I could put that into Desmos. And when I do that, just do that very quickly. When I do that, I see that the standard version of that number is going to be 1024. So my standard version is 1024. Okay, so I have my expanded form, my exponential form. I have this rule right here because I'm multiplying 2 or more. I could do more than 2 exponential expressions with the same base. So then I add the exponents. This works because my base in both cases is 4. If I had a different base, it would not work. So I want you to go ahead and I want you to look ahead at the try these A, at the try these A, and I want you to work through this with a partner, and then when you have worked through it with a partner, go ahead and check your answers with the video. Great, so if I look right here, I have x to the power of 2, would be this part right there, and I would have x to the power of 3. So now it's asking me to simplify this expression. So x to the power of 2 plus 3, I would have x to the power of 5. And that's as simple as it gets. I can't write this in standard form because I don't know my value of x, so I can only write it in the expanded and in the exponential form. Great. All right, so once again, we're going to take these expressions and we're going to simplify them. When it says simplify, you can just write it in the exponential. You don't have to write it in standard. All right, so here, 3 to the power of 9 times 3 to the power of 3. I want you to hit pause right now, and I want you to try these on your own. And then I want you to hit play and check your answer. So you're pausing. All right, here you should have 3, and then 9 plus 3 would be 3 to the power of 12. And if you wrote that out, you would have 3, you would have that 9 times. So that's your 3, and then 2, 3. This is going to take too long. There we go. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have 1, 2, 3. All together, I have 12. There's 3 to the power of 12. So over here, I would have a to the power of 11. And I got that because I did 7 plus 4 equals 11. Great. So now we have our multiplication with exponents with the same base. So now we're going to get into division. So it's important to note that for division, there's a couple things that we need to remember. In division, it's signified by a fraction bar, and that's how you'll often see division in 8th grade and in algebra. Fraction is the same thing as division. On the top of division, we have the numerator, That's important to know. And then on the bottom of division, we have the denominator. Okay, those are two important vocabulary terms to remember. So over here in our numerator, we have 7 to the power of 4. 7 being our base and 4 being our exponent, and that's over 7 to the power of 3. So we're going to take this exponential form and we're going to write it in expanded form. So 7 to the power of 4 is 7 times 7 times 7 times 7. There's 4, so it's the base times itself 4 times, and then that's over 7 to the power of 3 right there. Now, if you remember correctly, a number written over itself equals 1. Okay? And then 1 times any number is that number. So we oftentimes don't write 1 and then multiply it by a number because it doesn't change the identity of the number. So what happens is we end up doing what we call canceling them out. Okay, so here 7 cancels out to 7, so I end up with a 1 times 7 cancels out the 7 times 1, so they're basically canceled. They're canceled, and I end up with, sorry, let me add my other 1, so cancel, cancel, cancel. So I end up with just 7. Now, just to reaffirm our identity property, 1 times 1 is 1, times 1 is 1, times 7 is 7. So these ones right there, they don't change the identity, or they don't change the value of the number, so we oftentimes don't write them. So now here, 7, that's the same thing as writing 7 to the power of 1, but again, because that 1 does not change the identity, we would just write 7. So right now, looking at what we just did, how would you go from 4 to 3, and how would you get, I want you to talk for a minute, how would you go from 4 to 3 to get 1? That's right, you would subtract. So 7 to the power of 4 divided by 7 to the power of 3, you would do 7, 4 minus 3, because they all cancel out there, and then you would get 7 to the power of 1, which is the exact same thing as just saying 7. So let's take a look at one more example before we add that to our notes. So let's go to the try these B. It says rewrite the expression with the numerator and denominator in expanded form. So my numerator is x to the power of 8, which means x times itself 8 times. 6, 7, 8. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then my denominator is x to the power of 5. So 1, 2, 3, 4, 5. All right, so there's my x to the power of 8 as my numerator, my x to the power of 5 as the denominator. Excellent. So now I'm going to use a different colored pen. Let's see. I want to use purple. All right, and I'm going to simplify this. So these cancel, meaning they really just make 1, but 1 doesn't change the identity, so I say that they cancel. Those cancel, those cancel, those cancel, those cancel. All right, so what I'm left with in my numerator, I have nothing in my denominator. I'm left with x to the power of 3 over 1. And once again, that dividing by 1, it doesn't do anything to change it, so I don't have to write it. So now the way I could do that without doing all of that in expanded form is describe how you could simplify the original expression without writing it in expanded form. And the way I could do that is I could have just done 8 minus 5 equals x to the power of 3. So I could have just subtracted my exponents because I had the same base. So now I want you to turn and talk, and I want you to answer this question. What pattern do you notice about exponents when dividing two powers with the same base? So what pattern do you notice right there? Turn and talk, go. Right, you should have said that you can just subtract the exponents. So now I want us to go ahead and I want us to add that to our notes. Okay, so in your notes, you should add that when dividing exponent expressions with the same base, you keep the base and subtract the exponents. So we're going to go ahead and we're going to give ourselves an example. So this example, once again, we're going to go ahead and start with expanded form. For example, and let's see, this time I'm going to go ahead and I'm going to do an algebraic example. No, I just did that. So I guess I'm going to use my favorite number again. My favorite number is 4. So 4 times 4 times 4 times 4 divided by 4 times 4. So if I were to write that now in exponential form, and you can try to do this before I do, it would be 4 to the power of 2 over, to the power of 4 over 4 to the power of 2. My numerator, my denominator. So now I could take this, and they cancel, but instead of doing all of that work, I could just say 4 to the power of 4 minus 2, which is the same thing as saying 4 to the power of 2. And if that was hard to see because I kind of squished it in there, I just want you to know that it's 4 to the power of 2. So now same thing here, if I were to write this in standard form, 4 times 4 is 16. So my standard form is 16. Either of these two would be considered a simplified expression. Okay? Great, so now we're going to jump to the check your understanding, and you should be doing this as I'm walking through it with you, and it says simplify the expressions. So here I could write 12 15 times, and I could write 12 10 times. Or I could just remember my rules, and I want you to pause and you try this. Try this on your own, and then push play, and you'll check it. Great, so you should have 12 to the power of 15 minus 10, which would give you 12 to the power of 5 as that simplified expression. For the second one, even though it's not written, this bottom denominator is r to the power of 1. So here I have r to the power of 9 minus 1 equals r to the power of 8. So that is my simplified expression. Okay, now don't worry about doing number 11, but I want you to try number 12, and then in your composition books, I want you to do number 13 and number 14. Okay, this here, answering these two questions, this is your summary of your notes. And then if you need it, which you may not need it, but great sentence starters are when multiplying terms with exponents that have the same base, and then your second sentence when dividing terms with exponents that have the same base, Okay, so those are your two sentence starters. So you're doing number 12 in the Springboard, and then you're doing 13 and 14 in your composition book, and you're considering these the summary of your notes. And I will provide Spanish sentence starters as well. Great, so here are your sentence stems for your summary in your composition book in both English and Spanish. Go ahead and summarize it in whatever language you prefer.